There is a machine operating in open-pit mines right now whose bucket, just its bucket, the steel container at the end of its arm, holds more material than a standard construction dump truck can carry in its entire bed. Not slightly more, significantly more, enough more that comparing the two feels almost unfair. And this bucket does not fill slowly. It does not take a careful, deliberate pass across a prepared surface. It drives into a solid rock face with a force measured in hundreds of tons, tears free a chunk of the Earth's crust, and lifts it against gravity in a single fluid motion, high enough to swing over the side of a haul truck and release. The whole sequence takes seconds. And then it happens again, and again, until the haul truck is full, which takes 3 passes. 3 passes to fill a truck carrying 363 metric tons. This is the Bucyrus RH400, the largest hydraulic mining excavator ever built. A machine so large that the word excavator, a word most people associate with construction sites and residential foundations, barely begins to describe what it is. The RH400 is not a construction machine that happens to be large. It is a purpose-built industrial system designed to operate at the intersection of maximum mechanical capability and extreme operational reliability. And the story of how it came to exist, what it can do, and what it changed about the mining industry is one of the most compelling engineering stories of the last half-century. But before we get into the machine itself, before the bucket capacity, before the hydraulic pressures, before the engine specifications that will genuinely shock you, we need to talk about a competition that reshaped the entire large mining excavator industry, a competition between 2 fundamentally different approaches to the same problem. And the outcome of that competition determined what large-scale surface mining looks like today. For most of the 20th century, the dominant excavation tool in large surface mines was not a hydraulic excavator. It was a rope shovel, a machine that used cables and drums, rather than hydraulic cylinders to drive its dipper through the material and lift its load. Rope shovels, sometimes called electric rope shovels or power shovels, had been the workhorses of surface mining for decades. They were powerful, reliable, and capable of handling the hardest materials. Manufacturers like Bucyrus and P&H had refined them over generations into machines of extraordinary capability. And they were large, genuinely large, with dipper capacities measured in tens of cubic meters and operating weights measured in hundreds of tons. But hydraulic excavators had been gaining ground throughout the second half of the 20th century. Smaller and more maneuverable than rope shovels, hydraulic excavators offered advantages in versatility and cycle time that made them attractive for operations where flexibility mattered. The question was whether hydraulic technology could scale up to match the raw capacity of the largest rope shovels. Could a hydraulic excavator be built large enough, powerful enough, and robust enough to compete at the highest production levels in the world's largest mines? Bucyrus, one of the oldest and most respected names in mining equipment, a company that had been building mining machinery since 1880, decided to find out. The result was the RH400. And what happened when it entered operation changed the answer to that question permanently. But that's not even the most incredible part. Because the engineering challenges Bucyrus faced in building the RH400 were not just about making things bigger. They were about making big things work reliably in conditions that destroy less carefully engineered equipment. And the solutions they developed defined the state-of-the-art in large hydraulic excavator design for decades. The Bucyrus RH400 has a bucket capacity of approximately 94 cubic meters in its largest configuration. 94 cubic meters. To visualize that volume, imagine a standard 20-foot shipping container, the kind you see stacked on cargo ships and carried on trucks across the world. That container has an internal volume of approximately 33 cubic meters. The RH400's bucket holds nearly 3 of those containers worth of material, in a single scoop, lifted off the ground, swung over a truck, dumped, in seconds. The operating weight of the RH400 is approximately 980 metric tons in its fully equipped configuration, nearly 1,000 tons. For context, a fully loaded Boeing 747-400, one of the largest passenger aircraft ever built, has a maximum takeoff weight of approximately 412 metric tons. The RH400 weighs more than two fully loaded 747s combined, and unlike the 747, the RH400 sits on the ground, all of that weight pressing down through two crawler undercarriages onto the mine floor below. The machine's overall height, with the boom raised to working position, reaches approximately 21 meters. 21 meters. That is roughly the height of a 7-story building. A machine that stands as tall as a 7-story building moves on crawler tracks and swings a bucket the size of 3 shipping containers through the air at working speed. The visual experience of standing near a working RH400 is one that mine workers consistently describe as genuinely surreal. A scale of movement at a scale of mass that the human visual system was not designed to process as a single coherent object. The reach of the RH400's arm system allows it to dig to a depth of approximately 9 meters below the machine's standing level, and to reach material at a height of approximately 21 meters above grade. This working envelope defines the size of the bench face, and a single RH400 working a bench face within its optimal working envelope can achieve production rates previously only possible with multiple machines. Now let's talk about the number that defines the RH400's operational significance. 3 passes to fill a 797F. The Caterpillar 797F has a payload capacity of 363 metric tons. To fill it in 3 passes, the RH400 must deliver 121 metric tons per pass. At the bulk density of typical mining materials, 121 metric tons corresponds to roughly 50 to 60 cubic meters of material per bucket load. The RH400's 94 cubic meter bucket capacity provides sufficient margin to achieve this in 3 passes, accounting for the fill factor. 3 passes. The significance of this number is not just impressive, it is economically transformative. Because every pass the excavator takes to fill a truck is time during which the truck is standing at the loading point. In a mine where haul trucks cost millions, the number of passes is a primary determinant of system productivity. An excavator that fills a truck in 3 passes versus one that requires 6 doubles the truck's effective cycle rate. Across a fleet of 20 trucks operating around the clock, that difference compounds into a production advantage measured in millions of tons per year. This is where things get crazy. Because the economics of the RH400 cannot be understood by looking at the machine in isolation. They can only be understood by looking at the system, the excavator, the truck fleet, the haul roads, the processing plant. And the answer, in operation after operation where the RH400 was deployed, was dramatic. The RH400 is powered by 2 diesel engines working in parallel. Each engine is a large, high-output unit. Together, they produce a combined output in excess of 3,000 horsepower. These engines do not drive the machine's functions directly. Instead, they drive hydraulic pumps, large, high-pressure pumps that generate the hydraulic flow that powers every movement the machine makes. The boom cylinders that raise and lower the boom, the stick cylinders that extend and retract the arm, the bucket cylinders that curl and dump the bucket, the swing motor that rotates the entire upper structure. All of these functions are hydraulic. All of them are fed by the hydraulic system driven by those 2 diesel engines. The hydraulic system of the RH400 operates at pressures and flow rates that are, at the scale of a mobile machine, extraordinary. The working pressure in the RH400's hydraulic circuits reaches approximately 350 bar, 350 times atmospheric pressure. At this pressure, the fluid is moving at high velocity under enormous force. The cylinders exert forces measured in hundreds of tons. The hydraulic fluid management system is itself a significant engineering challenge. High pressure and high flow rate generate intense heat. The RH400's cooling system must handle heat rejection loads that would challenge many stationary industrial installations. The swing system deserves specific attention. When the RH400 rotates, it moves a mass of several hundred tons through an arc. The swing bearing is one of the most critical components. It carries the full weight and must maintain accuracy through millions of cycles. During initial testing, the heat generated exceeded thermal models. Engineers had to fundamentally rethink the hydraulic circuit architecture. The redesign process delayed the introduction, but it produced a machine that was more thermally robust than the original design. Reliability is the quality that mining operators actually pay for. A machine with 95% availability delivers dramatically better results. The RH400 was designed to be both capable and reliable. Achieving both at this scale required engineering discipline beyond simply making things big. The cab of the Bucyrus RH400 sits at the front of the upper structure, positioned to give the operator the best possible view of the digging face and the trucks being loaded. It is a sealed, pressurized, climate-controlled environment. The same dust exclusion and thermal management requirements that apply to every large mining machine. But the RH400's cab has a characteristic that distinguishes it from the cab of a haul truck or a bulldozer. The operator is watching the bucket work at close range, from a position that provides direct visual feedback on what the bucket is doing, how it is penetrating, how it is filling, whether the fragmentation is right for efficient loading. This direct visual feedback is one of the reasons experienced RH400 operators are so valuable. The data systems provide quantitative information about what the machine is doing, but the operator's visual assessment provides qualitative information. Is the material fragmenting in a way that allows efficient bucket filling, or does the blasting need to be adjusted? Is the bench face developing geometry that will create safety hazards? Is the truck positioning allowing optimal loading? These judgments, made over a 12-hour shift, determine the difference between 80% and 95% productivity. At this scale, that 15% difference represents an enormous quantity of material and money over the course of a year. The operator interface in the RH400 has evolved significantly through the machine's production history. Early units relied on the operator's skill, while later variants incorporated increasingly sophisticated electronic control systems. The payload management system uses sensors in the boom and stick to estimate the weight of material in real time. This allows the operator to judge when the bucket is adequately filled and adjust technique to achieve target payloads. The system transmits data to the mine's management system to track productivity and monitor truck loading accuracy. Consistent target payloads matter enormously. An underloaded truck is leaving productivity on the table on every cycle. An overloaded truck is accelerating tire wear and increasing frame stress, potentially voiding manufacturer warranties. The RH400 is not just an excavator. It is the loading point in a production system. An RH400 operating at its best makes its entire associated truck fleet operate at its best. But the RH400 story goes beyond individual operations. It changed something fundamental about the global mining equipment industry. Understanding that change requires looking at the competitive landscape that the RH400 entered and transformed. When the Bucyrus RH400 entered production, it faced a market dominated by rope shovels. The largest rope shovels of the era, machines built by Bucyrus itself and by competitor P&H mining equipment, had dipper capacities in the range of 40 to 60 cubic meters and operating weights in the range of 1,000 to 2,500 metric tons. They were proven, reliable, and deeply embedded in the operational practices of the world's largest mines. Changing from rope shovels to hydraulic excavators was not a decision mining operators made lightly. It required changes to maintenance procedures, operator training, spare parts inventories, and in some cases mine design and bench geometry. The RH400 gave mine operators a reason to make those changes. Its bucket capacity, approaching and in some configurations exceeding the dipper capacity of the largest rope shovels, removed the production capacity argument for staying with rope technology. Its hydraulic drive offered advantages in cycle time and maneuverability that rope shovels could not match. And its maintenance characteristics, easier access to hydraulic components, shorter planned maintenance intervals, and the ability to diagnose issues through electronic monitoring systems made the total cost of ownership case more favorable. The RH400's market impact was significant. In the years following its introduction, the market share of ultra-large hydraulic excavators in large surface mining operations grew substantially. Rope shovels retained important roles, particularly in the hardest rock applications where their structural robustness gave them an advantage. But the hydraulic excavator had proven that it could compete at the highest production levels. Bucyrus was acquired by Caterpillar in 2011, bringing the RH400 platform into the Caterpillar product family. Under Caterpillar ownership, the machine continued to be developed and refined with improvements to electronic control systems and fuel efficiency. The fundamental architecture, the two-engine hydraulic system, the large-diameter swing bearing, remained recognizable from the original design. The improvements were evolutionary rather than revolutionary, which is itself a statement about how well the original design was executed. The mines where RH400 units have operated read like a list of the most significant surface mining operations in the world. Copper mines in Chile and Peru, coal mines in Australia, iron ore in Brazil, gold mines in Nevada, and oil sands in Alberta. In every case, the machine was deployed because the production volumes required were large enough to justify the capital investment. There is a moment that operators and mine visitors consistently describe when watching a working RH400. The machine swings toward the face, the bucket descends, the stick extends, driving the bucket teeth into the rock. There is a brief pause, a fraction of a second in which the hydraulic system is building pressure against the resistance of the material. And then the material yields. A mass of rock that might weigh 100 tons or more breaks free from the face. The machine swings. The bucket, full now, carrying its 100-ton load as if the weight is irrelevant, swings over the truck. Opens. The material falls. The whole cycle takes less than 30 seconds. And 30 seconds later, it happens again. Watching this sequence repeat, you are watching a machine operating at the upper boundary of what hydraulic engineering can achieve. The engineering is invisible in operation. That invisibility is the highest form of engineering success. The Bucyrus RH400 is the largest hydraulic mining excavator ever built. It fills the largest haul trucks in 3 passes. It represents the answer to a question. Can a hydraulic excavator match the performance of the best rope shovels? The answer, as the RH400 demonstrated, is yes. With engineering, with discipline, with the willingness to solve hard problems, yes. And the next machine we are going to look at did not compete with rope shovels. It is a rope shovel, the largest electric rope shovel ever put to work in a surface mine, the P&H 4100 XPC, a machine whose dipper tears through rock that would stop a hydraulic excavator cold. The numbers are extraordinary, the history is even more extraordinary, and we are just getting started.